Okay, so we also have to now be able to use identities, because in this case here, when I'm trying to solve this, I cannot solve for sine and cos at the same time. I can only solve for either sine or cos. So I need an identity to convert this from either the sine squared into a cos or cos into a sine. Well, we have an identity for sine squared into cos squared. So we're going to do that. Okay. So instead of writing this as 2 sine squared, I'm going to replace that expression with an equivalent cosine expression. So I end up with 1 minus cos squared x. Okay. Well, now I have a quadratic equation in terms of cos. I can solve these. So rewriting this, I get negative 2 cos squared minus 3 cos x plus 2 minus 3 is minus 1 equals 0. I'm going to get rid of that negative. So that's a quadratic equation I can solve by factoring. Okay, so then I end up with cos x equals negative 1/2. And separately I get cos x equals negative 1. So I have two equations I need to solve for the angle. So cos x equals negative 1/2. It looks like this. It's going to be in those two quadrants. Okay, so theta 1 is equal to 2 pi over 3. Theta 2 is equal to 4 pi over 3. That's going to be this angle down here in quadrant 3. The repetitions of these, the period is, there's no compression or expansion, so the period ends up being 2 pi. Okay? So there's the solution for that. I also have a separate solution for this. Cos x equals negative 1/2. Well, negative 1, not negative 1/2. Negative 1 is right there. So theta 1 is equal to pi. And it's going to repeat every 2 pi. Now, theta 2 is going in the other directions, which happens to be exactly the same. It's going to be 2 pi minus pi. Well, I'm just going to get the same. So there's actually only one theta there. Okay. If you were to graph this on a graph, this is a bounce because this is a double root. Okay, we have the same solution for theta 1 and theta 2. Okay, so for this next one here, again, we have sines and coses. Now I can use an identity. I can convert the sines into cos using Pythagorean. Okay, I can convert the cos into sine using Pythagorean identity. I'm going to do something slightly different. I'm going to use the double angle identity, because when I rearrange it like that, there's my cos to theta identity. Okay, so I've just rearranged it to generate the double angle. So I end up with cosine 2x equals 0. Well, where's cosine equal to 0? Right there and right there. Okay, so then solving this, I can get theta 1 is equal to pi over 2. It's got a horizontal compression, so it's going to be, I'll make that in a different color, horizontal compression. Period is equal to pi, so that's going to be n pi. This one here, theta 2 is down at 3 pi over 2. Well, in fact, it's just an overlap, right? Because we end up with n pi again. Okay, so these actually overlap each other. So you can give me both like that, but this by itself would be good enough. Okay. I'm going to show you that you could actually solve this slightly differently. We could actually just solve for like this. Sine squared equals cos squared. Well, where's sine equal to cos? At 45 degrees. Okay, so it's going to be equal to 45. Oops, sorry, I didn't actually solve this correctly, did I? Okay, so I just want to go back to that. This is actually 2x. Right? This is a 2x here. Okay, so that's 2x is equal to that, and theta equals pi over 4, and this is going to repeat every n pi. Okay, and then I have the same for theta 2. 2x theta 2 is equal to 3 pi over 2. So x is equal to 3 pi over 4. And again, the period is n pi. Okay, so going back to this one then, we could actually solve this slightly differently by making it equal, sine squared equal to cos squared. And they're equal to each other at 45 degrees. So this is where we get all these solutions. You get the 45, 135, etc. So this one, we can, if you want to solve this, we just do this. Now it's hard to solve this if you have it in different functions. So I'm just going to convert this to sine squared over cos squared, which really is tan squared. Okay, so where's tan equal to 1? Slope tan squared is equal to 1 at plus minus 1. So those are the 4 positions I'm going to have. So x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and what's that going to be? 7 pi over 4. And there's going to have repetitions of every 45 or every 90 degrees. Well, these are all overlapping solutions with these ones here. Okay. This one here, if you recognize that this is actually a double angle identity because we can't solve with sine and cos, we need to recognize that this is a double angle identity first, and then convert that into sine of 2x. Then solve that for sine. Next is going to be equal to -1. Where's sine equal to -1? It's going to be equal to -1 down here. There's only one solution. That's going to be equal to 3 pi over 2. Okay, so theta is equal to 3 pi over 4. And then again, because of horizontal compression, it's going to be plus n pi. Okay, so we're going to have a solution in quadrant 2, quadrant 4, quadrant 2. So it's going to alternate between quadrant 2 and quadrant 4. If you solve this for theta 2, you will end up with negative pi over 2, which is actually the same position as 3 pi over 2. So those are overlapping solutions.